I'm going to be explaining the mole concept. I have my own problem here, which is 27.3 times 10 to the negative 9 moles. And you times this by the number you get up here, and you have moles up here, so you have to cross it out. So you have to put 1 mole on the bottom, and then you cross them out. And over here, the problem says it's looking for the particles, which is atoms. So atoms is Avogadro's number, which is 6.02 times 10 to the 23. This is his number. This is the mole. So since you got this, you gotta multiply 27.3 times 10 to the negative 9 by 6.02 times 10 to the 23. So as we do that, you get, put this in the calculator in scientific notation. You get 1.64 times 10 to the 16 atoms. And that's your answer right there. Okay, so we have here is the mole. A mole is any substance is in the molecular weight of those substances in grams. For example, you have H2O, and it has a molecular weight of 18.0. And so the mole in grams of the relationship in the water is 1 mole. So H2O molecular weight equals 18, that equals 1 mole. Okay, and that's 18 grams right here. This is grams. Okay, so and that's it for this. And chemists use moles to help them out with like the mole concept by allowing them to weigh the amount of two substances. So as they use the mole, it helps them weigh the amounts of substances that they have. Okay. So you often want to know how many moles you have in a sample of a substance. Counting the molecules individually will be almost impossible. Even if you have a way to see the mole particles, it's still too hard to count them all, even if you have tiny samples. Moles count the numbers of molecules in a sample by weighing it. That's how you can count. That's how you can count the moles by weighing it. Okay. So by the way, the question was asking the recommended daily allowance of selenium of an infant is 27.3 times 10 to the negative 9 moles. It's asking how many atoms of selenium is this. So this is the atomic mass for selenium right here. You find that on the periodic table, and then you just multiply that by Avogadro's number, and then you get how many moles you want, and that's it. Okay, so thank you for watching my video on the mole concept, and I hope you guys learned and understand about it.